Welcome back. In the previous video, we learned the basics of add transactional and how Spring manages transactions automatically. In this video, we'll go deeper and understand what actually happens behind the scenes when we use add transactional. Let's begin. Imagine you have a service method like this: add transactional, public void create order, save order, update inventory, colon. Looks simple, right? But internally, Spring performs several steps. Before executing the method, Spring starts a transaction. Then it executes your business logic. If everything succeeds, Spring commits the transaction. If an exception occurs, Spring rolls back the transaction. Now, the question is, how does Spring do all this automatically? The answer is AOP and proxies. When Spring detects the transactional annotation, it creates a proxy object around your bean. This proxy intercepts method calls and manages transaction boundaries for you. You can think of it like this: client, proxy, actual service. The proxy starts the transaction before calling the real method and decides whether to commit or roll back afterward. Now, let's discuss a very common interview question. Why doesn't @transactional work on private methods? Because Spring's proxy can only intercept public method calls. Private methods are called directly inside the class, so the proxy never gets a chance to manage the transaction. Example, @transactional private void process payment, This will not work as expected. Always use public methods for transactional operations. Now let's talk about another common mistake: self-invocation problem. Consider this: public void method A, method B, all transactional public void method B, all the timebots. If method A and method B are inside the same class, the call to method B bypasses the proxy. As a result, the transaction may not start. This is one of the most common reasons developers think @transactional is broken. Next, let's understand declarative versus programmatic transactions. Declarative transaction, using annotations. @transactional public void save user /o. Spring manages everything automatically. Programmatic transaction, you manually control transactions using transaction template or platform transaction manager. Transaction template.execute status to /business logic, return null. Declarative transactions are simpler and are used in most Spring Boot applications. Now, let's discuss rollback behavior. By default, Spring rolls back transactions for runtime exception and error. Checked exceptions do not trigger rollback automatically. To roll back for checked exceptions, a transactional rollback for equals exception.class. This ensures rollback for all exceptions. Quick summary: @transactional uses Spring AOP and proxies. Spring automatically starts, commits, and rolls back transactions. Private methods are not transactional. Self-invocation can bypass transactions. Declarative transactions are preferred over programmatic transactions. Rollback happens automatically for runtime exceptions. Understanding these internals will help you debug transaction issues much faster and make you more confident during Spring Boot interviews. Thanks for watching. Don't forget to like, share, and subscribe for more Spring Boot tutorials.